Hello student, in this problem, the angular velocity of the crank OA is 600 rpm. Determine the linear velocity of slider D and angular velocity of link BD. When the crank is inclined at an angle of 75 degree to the vertical, the dimensions of various links are OA equal to 28 mm, AB equal to 44 mm, BC equal to B to C equal to 49 mm, and B to D equal to 46 mm, and the distance from fixed point O and the distance from fixed point O to C is equal to 65 mm, and from C to horizontal line, from C point to horizontal line it is equal to 11 mm. So this is the given in this problem. From this speed in this problem, first of all we have know the is speed of this crank is 600 rpm. So from this speed we have to calculate first angular velocity of this crank O to A or A to O equal to 2 pi n upon 60. 2 pi n upon 60. Here this is a step. 2 pi n upon 60 equal to 62.84 radian per second. 2 pi n upon 60, so 2 pi multiplied by 600 divided by 60 equal to 62.84 radian per second. This is a angular velocity of link A to O. So from this angular velocity we have to find out a linear velocity of link A to O, and it is v linear velocity VAO equal to VA equal to omega AO multiplied by OA, distance OA, and distance OA equal to 28 mm, and it is in meter, 0.028 meter. So from this we are getting the linear velocity of A VA equal to 1.76 meter per second. So this is a first of all introductory part of this problem, and I have selected this problem from RS Kurmi book. So first of all, whenever the problems come from finding out a velocity from relative velocity method, then first of all you are requested to draw a neat and clean diagram of a space diagram. Then after you are going to draw a velocity diagram. So first of all I just explain how to draw a space diagram. Is for this space diagram, select O point, and from this O point you have to draw first an angle given of 75 degree vertically in a third quadrant. Then you just draw a length of OA equal to 28 mm from O to A, or it may be a select distance into a compass and mark point A from point O as a 28 mm distance. Okay, so after that take a distance of AB which is equal to 44 mm in a compass, and select and plot and it select at point A, draw another arc of B. Okay, after that you have to draw a vertical line OC and take a distance of O to C equal to 65 mm, which is already given, and then take a distance of 49 mm into a compass, and from point C take another arc, and the intersect these two arc at point B. So now we are getting a point B. Okay, so after that take a distance of BD, which is equal to 46 into a compass, and mark a arc of 46 from point B. Then after take a distance of 11 from point C, draw a horizontal line, and the horizontal line and the arc intersect at point D. Okay, and note that point as a D. So here with and this D point is our slider. So here with we completed our space diagram, and angular velocity we have calculated AO, also a linear velocity of AO. Okay, so then after finishing this space diagram, move forward to draw a velocity diagram. So to draw a velocity diagram, we always draw a perpendicular to link given in a mechanism, all links given in a mechanism. So first of all, see in this problem there are two fixed points at O and at C. These two are fixed point. So mark this fixed point at a single point OC, and from this OC we have to start our vector diagram to draw. Okay, so first of all take a perpendicular to link OA and draw this perpendicular from point O to C. Okay, I just draw this O to C, and take a distance of 1.76 meter per second. Assume some suitable scale to draw this line O to A. Measure a distance 1.76 at a suitable scale. Okay, so after that from point A draw a perpendicular line to link AB. Draw a perpendicular line to link AD, and this line is perpendicular line to link AB. Okay, from point A, but we doesn't know the distance of AB. So after that we take another fixed point, that is C. This is a C, another fixed point, and from draw a perpendicular to BC from point C. This is a perpendicular line from point C, and it is intersect at point B. Okay, so here with we got another point as a B. Okay, so after that we getting the B point, draw a perpendicular to BD. Draw a perpendicular to BD from point B. This is a perpendicular from BD, and also draw a horizontal line of slider, because of in this problem the slider moment is in direction, that slider moment is only move in horizontal direction. Okay, so from point O I draw a horizontal line, and these two lines are intersect at the vector line DB, and horizontal line OD intersect at point D. So here we completed our velocity diagram. Then in this problem we have to calculate the linear velocity of this slider. this slider and its magnitude related to relative velocity only in horizontal direction. So take a measurement of a distance of vector OD, and it is our VD, and and this measurement is our velocity 1.6 of a slider. This is a 1.6. Then after in this problem we have to move forward to calculate the angular velocity of link BD. We know we also calculate the angular velocity of link BD. So link BD, so measure the distance of vector BD, measure this distance in a scale. Okay, so this distance is 1.7 meter per second, and by using some suitable scale, so we got this answer 1.7 meter per second. And uh, this vector, so now we have to calculate the angular velocity of link BD here. Okay, so in this, angular velocity of BD equal to V velocity of dP divided by length BD, and 1.7 divided by 0.046, it is in meter. Okay, but problem it is given in 46 mm, so we have to take it meter. So 0.046 meter, so equal to, we got the answer of 36.96 radian per second, and it is in clockwise about to point B. So here we completed our problem. If any query, then you feel free to ask me. Okay, thank you.